Welcome to Proof of DeSci, the space where we dive deep into the world of decentralized science, where real research meets real world impact. And today we've got a fascinating episode lined up, so let's just jump right in. We're joined today by David-san Kong, Director Community Biotechnology Initiative at MIT Media Labs. Hey, David, how are you?
Hello, I'm doing great.
Thank you.
Great.
We also got ValleyDAO's very own Albert and Dan. Hey, guys.
Yay.
Sweet. Fantastic. So, yeah, we're going to be exploring David's work at the How to Grow Almost Anything, some of his new initiatives he's involved in. We're also going to dive deeper into our latest Straight from the Valley Labs project update, Cocoa Zero. So let's dive right in, guys, and especially David. So could you just give us a little introduction to yourself, to your persona, and can you explain to us a little bit more about the program, the How to Grow Almost Anything program, and what it does actually, what it aims to accomplish?
Well, it's great to be here with you all. Again, David-san Kong, I direct the Community Biotechnology Initiative at the Media Lab at MIT. So How to Grow Almost Anything, it is a MIT and Harvard and also global synthetic biology course. So one of my big research interests is in transformative learning, and also transformative learning at scale. And so there's a really, I think, rich tradition at the Media Lab of taking a transformative learning experience connected to a technology. So this could be coding, this could be digital fabrication, taking a learning experience, something like Scratch, which you may be familiar with. It's a coding environment and language that teaches really anyone, but in particular kids, how to code. And Scratch was developed by my colleague, Professor Mitch Resnick. And then now there's over 120 million users, I think, that have worked with Scratch. I'm guessing you may have interacted with it, or if you have kids, your kids may have. And then Scratch was then scaled using a network of physical spaces called computer clubhouses. So there's a really kind of critical dimension of this around network and scaling and using a node-based network model. And similarly, my colleague and Professor Neil Gershenfeld created a course at MIT called How to Make Almost Anything, which is a digital fabrication course. And he scaled that course globally using the Fab Lab network, which your listeners may also be familiar with. It's a network of several thousand maker spaces, but again, branded specifically for these fabrication laboratories. Through the course, you learn all about the ins and outs of digital fabrication. So how to do additive, subtractive manufacturing across scales from, microns all the way up to, architectural scale buildings. So I think that's another really beautiful example of taking a technology like digital fabrication, developing a transformative learning experience, i.e. how to make almost anything, and scaling it globally with a network. So we are doing the same thing with synthetic biology, biotech, life sciences through How to Grow Almost Anything, which I teach with Professor George Church, a whole amazing crew of faculty, synthetic biology faculty from around the world, from academia, industry. It's a really kind of a who's a list of folks in synthetic biology. And every week we teach you a topic at the cutting edge of SynBio. This could be, but also covering the foundations and fundamentals of SynBio. Things like, read, write, edit DNA, how to use artificial intelligence and machine language for protein design. So a lot of the latest tools, things like, AlphaFold 3, RF diffusion, et cetera, genetic circuit design, biological production, biofabrication, and beyond. And so you learn a skill every week. You get exposed to topics at the cutting edge and also the foundations of SynBio. And then it culminates in a project where the students take all those skills and then they make a project that's personally meaningful to them. So I think also to shout out the 4 Ps of learning, which I think is a really key pedagogy that we have at the Media Lab around passion, peers, projects, and play. And so one thing that's really important for us is that, you learn based on stuff that you personally really care about. And so that's I think an important feature of all the different courses and learning platforms I just described. Anyways, that's kind of the high level of the course itself. But I think part of what's relevant to this conversation and exciting is, again, we're also scaling How to Grow Almost Anything with a global network of regional nodes. So this year we have operationalized nodes in New York and San Francisco, London, Victoria, and Ottawa, Canada, Quito, Ecuador, in Korea, and also in Japan and Tokyo. So those are physical spaces you can go to take the course alongside the Harvard and MIT students Or if you're in the same time zone, at least you can participate as a virtual learner as well. So yeah, it's been really kind of amazing seeing the growth of the course over the years. Last year we had like more than 550 students that we accepted from around the world. This year, almost 1,300, so we more than doubled. And yeah, we're kind of in this moment of exponential growth right now and the scaling of our network. And I'll pause right there, but I think that's just a bit of a highlight, at least on the course and some of my research interests.
Absolutely. Go ahead, Albert.
Yeah, David, I would love to know what are some of the projects that you've seen that people have worked on that are like super memorable to you. I would love to hear, some examples.
Yeah. I mean, there's so many over the years. We've had students make like optogenetic wearables for producing molecules on demand for space exploration, or, spider silk spacesuits, or textiles augmented with engineered organisms that are temperature and pressure sensitive. Or actually, there's one story I love of a student who is a city scientist and was very much into building and testing sensor networks. And so through the course, he decided to build a live cell biosensor in an open source bioreactor. And that project got turned into part of his thesis, which then got turned into a paper. And then that open source design got picked up by a student the following year, who then used that bioreactor to study organisms in their indigenous to Hawaii, where that student was from. So the projects they're really kind of vast in their scale. And there's computationally designed, proteins for breaking down plastics, DNA canvases and DNA nanostructure designs. It's really kind of the full breadth of what you can imagine in synthetic biology, because it's again reflecting the interests of the various students.
I love it, and I can imagine, given that it's sort of like a course you take alongside a community, so everybody helps shape each other's projects and provide feedback. And so I can imagine it's like a really valuable environment to be in as well, especially if like you're like early career scientists, or even I've also noticed there's like a lot of senior people as well. I want to meet seniors like 30 plus, 40 plus participating in this. Yeah, it's just like super cool to see.
No, for sure. Yeah, I think you hit on a couple of things that I think are particularly interesting. So one, you don't have to have any prior biology background to take the course, which is a pretty big deal. And my colleague Mitch Resnick has this idea around like low floors of learning. So one big question for me, when you think about scalability, I'm very inspired by Mitch's number of like over 100 million users in Scratch. And so I think a lot about similar questions. How do we get 100 million learners engaged in biology, right? And so I think the idea of having the course be very accessible is really important. So if you don't know the difference between a DNA molecule and a protein, we put you through this week-long boot camp in January, and you learn about, kind of central dogma biology, the fundamentals of experiments and scientific method, fundamentals in coding. And then that kind of gets you in the door so that when the course starts, in February, you can hang, you can hang. And then, obviously putting in the effort, you can really get a lot out of it. But yeah, I think so we see this huge variety of students. There's so many artists, designers, computer scientists, material scientists, engineers, mechanical engineers, kind of you name it, we see it. And we see all the way from, high school students all the way to retirees and everybody in between. So it's a really super diverse course in terms of the folks that participate, which is part of what's awesome. And exactly to your point, the course is like the opposite of a MOOC in the sense that, it's not you learning by yourself with a computer. It's you using a computer, but learning with a cohort of peers. So we have an asynchronous kind of platforms that people use to communicate and work together with on. And then all of the students in the course are a part of these nodes, as I mentioned. Obviously at Harvard and MIT, you're in person with us in Cambridge, but if you're in Europe where you guys are, there's actually an amazing how to grow node in London called LifeFabs. If you guys are familiar with LifeFabs, they took on almost 100 students signing up from across Europe, actually. And so that's one of the huge parts of being able to learn alongside a group of peers. So the course is live, so you pop into the virtual classroom if you're from anywhere around the world, and then you're engaging with the recitations live with other students, and then depending on your time zone and your cohort, you'll then have kind of virtual classroom time with those peers in your time zone and with your node. So that's definitely a huge part, Albert, is the peer-based learning part, which is, we all learn better when we're able to exchange ideas and get inspired by others.
I'll pass it back to you, Tom.
Sure. Thank you, Albert. That's all absolutely incredible, David. And I'm actually wondering, because obviously this is proof of DeSci, and we're here to also discuss DeSci. What do you think, from your perspective, what role do you see DeSci playing in making the kind of innovations you're working on and you're helping to build kind of more accessible to the wider world? Do you think that DeSci is here to actually help? What's the connection?
Yeah, that's an awesome question. I actually would love to hear your guys' thoughts as well about this. But I think to me, certainly thematically, technologically, it feels like there's a tremendous space for overlap and collaboration and synergy between something like How to Grow and DeSci. Obviously, what we're doing is inherently decentralized science. That's literally what the kind of the name of the game is, and at least as it relates to our network model. And one thing that's been really exciting for me, last year we started doing what we call network-wide collaborative research projects. Okay, so if you think about it, everybody is working on an individual project, which is amazing. And then, sometimes there are like little subgroups that spin off. It's like, for example, we've had students that'll do like a computational project where they're doing, one person's doing a lot of informatics and protein design. The other person is then synthesizing and testing that protein, for example. So you might have the little clusters of people working on similar projects. But last year we started having the whole network focus on projects together, right? And so, I'm guessing your audience is probably familiar with iGEM, the International Genetically Engineered Machines competition. And it's not the anti-iGEM, but it's sort of like, instead of having kind of different labs or spaces compete, it's like, how do we collaborate and work together to solve and work on collective problems? Right? And I think, if you kind of zoom out a little bit and think about what's going on in the world right now too, I think it's important for us to imagine infrastructure and ways for us to be collaborating broadly, globally on so many of the big challenges that we're all facing. So I'll give you an example. In spring 2024, we started a project around basically global health and antimicrobial resistant bacteria. So, one of the big emerging global health threats is around antimicrobial resistant microbes, and an interesting potential therapeutic are bacteriophage, right? And so we had the students all at MIT, Harvard, and around the world design their own lysis proteins. We had those protein designs synthesized. So we got the synthetic DNA, and then we used a collaboration with a company called Nuclera. Nuclera does chip-based cell-free protein expression, and these were with DNA constructs from our collaborator and dear colleagues at Twist Biosciences. And we basically did on-chip expression of all of these different protein designs, and then showed which ones performed better than the wild type, and so on. And you can basically see the kind of different ways that the student designs perform. And now we're working on these different kind of activity assays on their efficacy. It was a really kind of cool way, an example where, you can have the whole network working on a problem, and you can imagine doing things like, doing a large scale kind of parameter scan like we did in that first round where you're looking at, hundreds of different protein designs. And then you can do reproducibility studies where you get the network to focus in on, a small number of candidates, et cetera. And so those types of kind of experimental modalities we're starting to play around with now. I'll give you another example of a project we started just this past spring, which I'm really excited about. So one of our faculty is Professor Ron Weiss, who's the director of the Synthetic Biology Center at MIT. And there's a doctoral student in biological engineering, also in part of the Media Lab, Evan Holbrook, who has been working on a project called neuromorphic circuits. So it feels a little sci-fi, but it's basically, genetic circuits that when transfected into mammalian cells, the cells behave a little bit like a neural network. And in some kind of more advanced versions of it, the cells are hopefully even potentially able to edit their own DNA. So it's sort of like a cell that can learn. And what we had the students do was to design their own neuromorphic circuits. And this is a pretty far out in some ways set of mathematical concepts that even, somebody like Ron is still kind of grappling with. But it was amazing. We literally had students who had never done any, didn't know what DNA was before several months ago. And now they're designing their own neuromorphic circuits, programming liquid handling robots to then assemble those circuits and then transfect mammalian cells. And then, so Evan basically had a whole big slew of circuit designs from students all around the world and from MIT and Harvard. and then built those circuits, and then with robotics, and then tested them with flow cytometry at MIT to look at the circuit design. So that's another kind of really cool example where you can leverage the power of the network, have tens, hundreds of different designs or more, thousands even, being generated and then assembled and tested. And, another thing I forgot to mention earlier, one of the real secret sauces where I think we can get to large scalability on the scale of, tens, hundreds of millions of people is actually robotics, right? During the pandemic, we were faced with a situation where, we had this very hands-on experiential learning course, the synthetic biology class, and then, students can be in a wet lab. So our big solution was to teach the students how to program robots. And so we taught them, Python, and then they could basically do remote biology, right? They could do cloud biology, and you could be in your dorm room across the street at MIT, or you could be, Accra, Ghana, or in London, and send over code and program robots at MIT. And so that got us really excited about this vision for cloud-based learning and robotics-mediated learning. And that, I think, is another huge part of how you can get to this other dimension of scale. And so we actually published a Nature Biotech paper on this about 2 years ago. Our audience can check out. And anyway, so I think, this question around DeSci, to me, something like what we're building out, where we've got infrastructure, where each of these nodes has, for the most part, some type of liquid handling robotics that have code that's interoperable and diffusible throughout the network. And then you've got data that also can be shared throughout the network, protocols that can be shared. There's a really cool way, I think, in which collective science can be done using this type of an infrastructure. And so that's what I'm working on, and what, again, our colleagues that are part of this journey with us are working on. And I'll kind of throw your question back to you a little bit, which is like, okay, given all of that, how does that plug into DeSci? Because I feel like there's a lot of really both thematic and probably technical places where they do connect. But yeah, curious actually your guys' thoughts based on what I just shared.
I love that. I can say, I wrote a tweet earlier, David Kong was doing DeSci before it was even a thing. I mean, DeSci is just a new term or an alternative term, or what people that are interested in Web3 like to use. But by the end of the day, it's very similar to open science, open source science. It's like the same ethos, same type of values. And I think something that you are, taking a really good stab at with how to grow is the educational aspect. And to date, there hasn't been that many DeSci projects, or at least I can't name one that would serve as a good example of DeSci education. I mean, the education is an extremely big an important aspect of science, because if not enough people know what the science is about or how to use it, then that scientific field is not going to really take off or improve. So that's like how I see the work that you're doing at How to Grow. It's serving a core need in the ecosystem, and that is really education. And I think iGEM does a great job at I think they every year they're now up to 5,000 to 6,000, but they're sort of like tapping out at that number because in person is limited by space, right? And you can't host like an event for 20,000 people and have it be meaningful for all of them. And of course, iGEM comes with a certain cost to attach to it. Whereas what you're doing is you are centralizing that experience for people and making biotech real for more people. Because if you ask the average person on the street, what is biotech? I mean, usually they say oh, it's something medicine, something biopharma, but biotech is, way more than that, right? Okay, it's a manufacturing technology. We can make medicine, but we can also use it for art. We can use it for proof of concept of new materials that previously haven't even been conceptualized. And ultimately, biology is limited by people's creativity, in my view. And so you're opening up that door for people globally. Yeah, that's why I'm, a big fan of yours. And that's why we call this show Proof of DeSci, because we want to prove to the world that DeSci is actively happening. And it's not always that people use the term DeSci. Yeah, just my thoughts on that. I don't know if Dan, you have some other thoughts on that too.
No, I mean, one quick thing. Oh, sorry. Just one quick thing, Albert. You said a lot there that I thought was really interesting. I agree with you very much that I think synthetic biology and through courses like How to Grow is able to kind of invigorate other imagination around what biotech is. And I'll point you to actually a really interesting document that just came out this week from the National Security Commission on Emerging Biotechnology. So this is there's a bipartisan commission in the United States, which is it's like a miracle of God almost to say something that could be bipartisan in the United States. But it's a report that talks about the need for bioliteracy, and that there is this kind of emerging both national and global bioeconomy, and much of it is actually going to be driven by bioindustrial manufacturing. And so this goes, Albert, to your point around, materials, the kind of stuff of the physical world, including things we eat, things we wear, things that are part of our environment. And so a lot of that is going to be grown in the future. It's increasingly being grown now, but it will continue to be done so in the future. And so yeah, I think there is a real urgent need for all of us to have more kind of bio fluency or bio creativity. I think it's interesting, right? Like we all take for granted digital literacy, right? All of us every single day interact constantly with computers and the internet. And I'm old enough to remember when there was no, ubiquitous computing and internet. You know what I mean? And so it's amazing like how much has changed in a few decades. And I think there's going to be a similar type of experience that already is underway with biotech. And certainly I hope How to Grow is a big part of that process of, kind of increasing access, making it so as long as you've got an internet connection and a computer, you can participate, you can learn, you can feel a sense of agency and, connected to communities of people around the world with similar values and care. And so yeah. And I think I personally would love to, figure out how larger DeSci as it relates to Web3 connects with what we're doing. Because certainly as you were framing it, Albert, I think How to Grow is very much an exercise in open science and DeSci. But I'm guessing there's also other kind of technical particulars to plug in more directly into the Web3 parts of that. But certainly philosophically and thematically, I think they're very linked.
Incredible. David, like I'm listening to you and it's honestly admirable what you do and your passion to educate people as well, and teach them about biology, about biotech is highly inspiring. But I wanted to ask you a little bit more because you've obviously built a huge platform for people to learn biology. What were the biggest challenges and what are the biggest challenges still that you're facing? And do you think if there's any kind of barriers that DeSci and biotech may be approaching or has?
Yeah, it's a great question. Obviously there's so many challenges. I think anybody trying to do anything hard out there in the world, you always got to navigate a lot. One thing that comes to mind, I think that's interesting is, so one set of challenges is like, how do you take something, sets of very complicated technical concepts and skills and create the right types of communication and activities and engagement to then have that become accessible, right? It's, my colleague, George Church, who I've been working with for years and I love dearly. George, if you get him going on, XYZ topics in synthetic biology, you'll start feeling like, wait, did we just solve climate change in like one PowerPoint slide? Is that just what happened? So there's, I think, definitely challenges around just kind of translation, right? And it's very possible to do, and it's taken a lot of time over the years to try to find the right metaphors and activities to get these technical concepts communicated and embodied in the right way. So that's one part. And connected to that, though, I think, one part of scale that I haven't totally figured out yet, but also I think is one huge part about How to Grow that I think makes it work is a very high touch from mentors and instructors. And so, we might have, hundreds of students at any given time, but we try to keep the number of teaching assistants that we have and mentors also very high. And so one part that's been beautiful we've seen is this kind of virtuous cycle where after you take the course, you then join the next year as a TA. So like, I think the past 2 years, we've had like almost 100 plus teaching assistants globally. And the majority of those TAs are former students. So, and it's grown every year, the number of TAs. So we've gotten this really kind of beautiful cycle where the learning community and the teaching community gets bigger and bigger every year. And we've also seen now a handful of cases where TAs become faculty. So we've actually had one of our former students, Thras, who was in our first cohort, was a student, was a TA, and then is now faculty. So that's been a kind of a cool thing to see. But because of the high touch, that's another kind of dimension of the scaling that's important, right? Every single one of the student projects that I mentioned ends up at this stage, we try to make sure that there's at least one mentor that can engage with that student. So, and again, we give constant kind of feedbacks and critiques throughout the semester. And it's really cool. So each node has their own kind of set of feedback process that happens. And the whole thing culminates, like this is actually, I'll send it out to your audience too, if y'all are interested. But the final project presentations this year, we're going to have probably like 10 hours worth of presentations over 2 days. I mean, it's like a wall to wall, kind of frontiers of, creativity and synbio type of day or day and a half, which is pretty epic. But anyways, I think that kind of, really authentic mentorship is something that is harder to scale. And you can do it virtually. And that's something I still am in favor of in a lot of ways, because, especially right now, I think there's a real need for like authentic connection amongst people. It's like, how do we try to imagine our ways into different futures if we don't have like real relationships with each other? And so, one thing I see a lot is that through mentorship, that is, quite high touch and involves, real connection and understanding, what a student cares about, why they're interested in this project, what are the things they're trying to get out of it. That's something that is, I think, almost more kind of like a grassroots connection feeling that is challenging to scale, but I think is actually necessary to scale.
Awesome. Thank you, Albert. Dan, if you want to jump in and if you want to carry on this topic as well, don't hesitate to, Albert.
Yeah, I want to give it to Dan because I think he was interrupted a couple of times. Dan.
Sorry.
No, don't apologize. I'm loving this conversation. How to grow it's so exciting and so important. It's really great to hear of the numbers and the stories. And it's just so exciting. I guess one thing I'm curious about is, who pays for the protein expression and, the chips and the reagents and all of that. And, I'm just kind of thinking about how DeSci can, kind of partner up with how to grow and help expand it and, continue its trajectory and scale. Because I think one of the few examples that we've seen in DeSci is, giving incentive for people to continue on with projects to the commercial stage, or at least along that route. And also to help kind of bring together lots of people to bring together small amounts of funding in a way that in cumulative can move the needle.
Yeah, that's a great point. So, another challenge and something that has not been solved, and potentially what you described could be quite helpful, is around the larger business model for how you get this whole thing to work, right, and to scale. So, currently, How to Grow runs on a lot of blood, sweat, and tears. It's a really the TAs, the instructors, we all donate our time. And, because we care about the mission, we see the impact that it has. So it's something that we all are excited to contribute to. And we see that same generosity as well from our industry partners. And so, again, a shout out, for example, like Emily LaProuse from Twist, who's been amazing. And as, Twist has donated us in-kind DNA synthesis every year. So we never have to worry about that. The students order what they want. Twist goes and prints it for us, which is amazing. Yeah, and over the years, the past couple of years, even like companies like Thermo Fisher, they've been so generous with reagents, equipment, Opentrons with robots, so Nuclera again with their system. So I think there's been a really beautiful way in which industry has stepped up to the table to help support. And we've been growing out our larger industry council. We now have, I think, about 21 companies that have partnered with us and are all contributing something. And that I think has been really amazing to see. Actually, like this recent kind of build out of the council is really kind of amazing. Like literally like every person I talked to, they all said yes, which was a pretty cool thing to see, that interest and the support. But even with all that, as you guys all know, French experimental biology is still expensive. You still need, even if you've got this node network, even if you've got people programming robots remotely, to your point, there still is like physical infrastructure that's required. And ideally, there should be business models to better support the labor, because so much labor is involved in here. And so I'll point to, one example. I mentioned earlier how to make almost anything in the Fab Lab network. And so they do have a business model there that is interesting and I think works and could be adaptable to part of how it grows. And I should mention right now, the course for virtual learners is totally free. So you can just, you apply, the application is really easy. We accept almost everybody that, really kind of shows that they care and they want to put in the time and the effort. And so, if you're virtual, you can plug in, participate in all of the lectures, recitations, et cetera, and engage in all the remote learning stuff. So you can do all the, AI protein design stuff. You can program robots, et cetera. And so anyway, so that's a one dimension. I lost question of the question. What was the question again, Dan? Sorry, I was like, it's on a little flow and then I forgot where I was going.
I feel like you were just getting there. We were just wondering who pays for the stuff that's not donated, I guess.
Thank you. Okay, yeah, the financial part. Yeah. So Fab Labs, they have a model where students pay tuition And half of that tuition goes to your regional node, and then the other half goes to the central organization. We're very likely to start spinning out a foundation or another nonprofit entity to help support the growth of the network. And colleagues at the Clubhouse Network have done this successfully. Same thing at the Fab Foundation. So we're likely to do something similar. Excuse me. So there are kind of tuition-based models. To your point, what you're hinting at, I think it could be really amazing to have there be some DeSci-related approaches to supporting the network, and in particular, the student projects, right? One thing that we see that happens every single year, the students, 'cause you all know, for your listeners probably know too, biotech, growing stuff is slow, right? It's not electronics. It's, that's not speed of light work. It's, it takes time for things to happen in biology. And so you can only get so much done in like a 14, 15 week, process. And especially, the final projects where you're maybe working for like a month and a half. And the students have done some really impressive stuff in a short period of time. You really only can kind of get so far. And this always happens every single year. And it gets crazier now, because just the sheer number of projects that we have. There are so many cool projects that need support where people want to go and do more, but don't have the resources necessarily. We try to do some of that support at MIT, but that's also very limited. So I think that would be an amazing area where DeSci could be really interesting. Another part too is also supporting the network growth, right? I think all of these nodes, and I should mention too, all of our how to grow nodes. You really the only kind of major requirement we have is that you can take on students, right? So you could be an academic lab, you could be a community lab, you could be some companies have their own kind of community labs within a commercial setting. So as long as you can take on students, we can work with you to become a node. And every node's different in terms of their technical capacity, right? Some are like full on, super equipped. Like we call our MIT, node, quote unquote, which is kind of how to grow central. We're like a super core site, right? Like we've got, access to mass spec and flow cytometry and all this stuff. But then there's some nodes that are way leaner and have very limited equipment and space and only are taking on a handful of students, right? And that's also great. So I think leveraging some of the DeSci infrastructure you're describing to help support the nodes, support the projects, all of that I think could be really, really awesome.
Yeah, I think one thing that we could support with already in the next iteration of how to grow is to help the different nodes and the different students in conceptualizing their research projects. So one platform that we're building now, Flow, it will be as simple as just outlining like what you want to do, what the goals are, and a couple of more info points. And then from there, it'll be able to generate essentially like an experimental plan, and it can help you think about everything from regulatory to even the ethics of the project if you want to go to that length. But just help conceptualize the idea and just catalyze that early stage of whenever you're starting a new research project fresh and you come from like no previous work, it can be a little bit of a friction to get started. So I think already there we could support in the next iteration of how to grow. So I would love to explore that with you as that gets closer.
Yeah, that sounds awesome. I mean, I think platforms like that help people newer to scientific inquiry and scientific method, asking the right questions, framing research. All of that I think would be really valuable. And I totally forgot to mention this. So we're like 39 minutes into this conversation. ValleyDAO, also shout outs to ValleyDAO for your support of how to grow almost anything. You guys provided some support to, totally. You guys actually provided critical support to help support that protein synthesis project that I mentioned earlier with Nuclera. We were able to use their digital microfluidics cartridges because of your guys' support. I think it was 2 years ago. So last year.
Can't believe it was 2 years ago. Wow.
Yeah. I guess it was technically, well, it was, we did the work spring last year, but I think we really kind of, got together to figure out the plan to support that research like in fall of 23, probably. So yeah, maybe it was a year and a half ago, probably.
Yeah. It's definitely been some time.
Yeah.
And I think one way maybe maybe you've looked into this already, but there are people out there with some sort of lab setup to do stuff like at their home or like in their garage. And one interesting aspect would be to explore matching those individuals with people with ideas that are taking the course, or maybe they could take the course at the same time. And then, one party, does the experiment, the other party just sort of like does the knowledge work and the review. And I think the ultimate outcome or the primary thing or the primary like metric of success perhaps for every participant is to just get some experiment done, whether it's yourself or somebody else doing that for you or the MIT lab doing that. So So I think trying to work in that engine could drive even more impact.
Yeah, that's actually a really cool. Yeah, the idea of like kind of, I mean, I mentioned before, we see this quite a bit where students will work together in like pairs or small teams on the topics. I gave the example earlier around, student that was kind of doing more of the informatics and protein design and, kind of really digging into the AI tools, and then partnering with somebody that was interested more of doing stuff in the wet lab and actually like making the thing. So those types of partnerships we see a lot, and we see that work really well. I mean, one thing that I think we're gonna start doing more next year, we haven't done it this year, is creating kind of project focus areas. You can kind of take like the larger field and break it down into a bunch of categories. And we see this also in terms of the companies that support us. Like there's definitely like a biomaterials thrust. And so it works out nicely when you've got other people working on, which again, you can kind of peer-based learning and connect with. But there's definitely a big thrust around biomaterials. There's definitely a big thrust around protein design. There's also, of course, a big thrust around biological production and manufacturing. How do you scale stuff up in fermenters? If you're going to make spider silicon, how do you actually go and make a large amount of that? There's also kind of, I would describe this as like fundamentals of like non-model organisms. In synthetic biology, obviously in bio, we spend a lot of time with the yeast, E. coli. There's a lot of effort right now in terms of thinking about, how do we move past those types of model organisms? And actually a project that I think would be really, really cool and would be very kind of DeSci and leveraging the network is study of regional biodiversity, right? It's like, wherever you are on planet Earth, if you're on an island, if you're in a desert, if you're, in a city, wherever, there's so many different microbiomes that are present. So I think that could be a really exciting global project or regional project that's kind of studying that, the types of organisms that are present, and then ways those organisms could contribute to making stuff. So anyway, so there's a whole kind of big world out there of different types of projects. And I think, Albert, what you're describing of, having, if you're not resourced, being able to engage in multiple levels of ways of interaction is very much what we're trying to set up, both as you described with robots and then also, potentially partnering with folks that some access or better access to labs.
I think a great way to wrap this up. David, I think how to grow needs its own Twitter. If you don't have that already, there's just so much to post about and talk about, and I think that could pull in a lot of more interest. Because that's what I want to see on my timeline. Like I want to see, even if it's just like a paragraph of a project that was done at the course, or maybe have that as a module in the course. It's like, by the end of the course, you need to write a blog post or you need to post about it on LinkedIn or just something like that to get your diploma or whatever you have, get it more out there.
I love that. We actually, we are on Instagram, we are on LinkedIn. I post about how to grow in my personal, kind of Twitter X account, but I agree. It would be awesome. And it's, one of the easiest bits of content, which we have so much of, is just the student projects. We've got like hundreds of these amazing projects, and you're totally right. We're definitely we are not doing what we should be, at least on the social media side of communicating the projects more. But I take that recommendation totally to heart, Albert. I think we're definitely trying to do more of that for sure.
I think Tom can definitely help on that front.
Great.
Amazing. Guys, I think it's good time to shift the gears towards the Cocoa Zero project a bit. Albert, Dan, can you give us an overview of where we are with the Cocoa Zero research at the moment, how the development of this sustainable cocoa butter alternative is progressing?
Yes, absolutely. So Cocoa Zero is probably a new name for a lot of people here because we've renamed the project to Cocoa Zero, and I'll go into a little bit later why we called it Cocoa Zero. But this is basically the name for the first funded ValleyDAO project taking place at Imperial with Dr. Rodrigo Ledesma Amaro and one of his postdoc students, Dr. Oliver Konzak. And what we're doing there is we are working with a special type of yeast that is really good at producing fats, and we're engineering it to produce fats very similar to cocoa. And why cocoa specifically? If you Google the price of cocoa, you'll see that it has just gone straight up into the ceiling. So if you invested in cocoa, you've made some money if there's a way to invest in it. And the reason for that being is a lot of these plantations are seeing a lot of droughts, a lot of extreme weather events that are essentially just flushing away the trees. And what's challenging with the cocoa tree specifically is that it takes 3 to 5 years for it to start producing the fruit, and then an additional 5 to 7 years to reach peak production. So that is the reason why like all of the different supply chains are being right now negatively disrupted, and the prices are going up. And I think biomanufacturing will play a much bigger role in producing these fats, because otherwise chocolate will be just way too expensive. And that's like the challenge that we're trying to solve with this project. And this project has been going on for approximately a year. And as of last month, we reached a pretty significant milestone in the lab. We were able to see that we can achieve the same fatty acid composition as that of the cocoa fruit itself. And so this composition is essential for the texture, the flavor, the mouthfeel, all of that, the melting point, for example. And we are right now in the process of partnering up with a chocolate manufacturer out of Switzerland to test these fats. So yeah, super excited to be sharing that with everyone. We'll be posting more and more about it. Our ultimate goal is to be the first DeSci chocolate brand, potentially. So yeah, we'll see how that goes. What I love about this project, it was fundamentally funded by the community, and there's just so many interesting directions this can go. This could be the first community-owned chocolate brand. I just find that fascinating, and just something that we haven't seen before. Now, how exactly that's going to play out, that's a future chapter to be written. But yeah, just super excited to share that with everyone. And Dan, yeah, anything on your end here on this project?
No, I mean, you said it perfectly. From my perspective, sustainable, means sustainable from a climate perspective, but also from, a price perspective. And can you get enough materials in the right places? Biomanufacturing has the potential to check all those boxes. So yeah, really excited about this one.
Awesome. And Dan, actually, maybe you can answer this question first. And obviously, David, if you've got any questions regarding the Cocoa Zero project and how it all works, feel free to jump in as well. But this turn we can do Dan and then Albert. So yeah, just like Albert said, in terms of the first kind of DeSci-powered chocolate bar, right? This milestone at Cocoa Zero, the Imperial London College research project, seems to be bringing us closer to creating a real-world impact. Something that we've been discussing in the previous Proof of DeSci episodes around hempy. How does the process of turning DeSci into a consumer product could work? What challenges do you think we're going to be facing in making this kind of shift from lab to market?
Yeah, so I mean, it takes partnerships. We're not going to be able to do everything on our own. But one like really powerful thing that we've been able to demonstrate so far is linking up community with researchers, linking up researchers with chocolate brands that are willing to do some early stage testing. And then, we'll continue that chain all the way down to, branding, marketing, distribution, regulatory, economics, like all of the things. So, it definitely gives us a good platform to align incentives and bring in all the stakeholders we need, but at the same time, keep kind of control and upside with the creators and the people who are adding value.
Yeah, I think it's just like, for example, with the Hempy project right now, like we're creating these sustainable hemp-based textiles, and we are in the process of producing the first proof of concept hoodie. And we have a particular like work group at the DAO with different contributors that just wants to see this happen, but also polish their business development skills on their way. So we're approximately a group of 5 people. We're doing everything from establishing the supply chain. So like, where are we going to source the raw hemp fibers from? Or where do we stitch together the clothing? How do we distribute that? We're creating a brand as well with, related to Hempy. And I mean, this is really where decentralized science, like the power of decentralized science really comes into play. Given that we are, working in a more open setting, it's accessible for people to actually come to the table and contribute with their skill sets, but also be rewarded for it at the same time, can really create a really powerful flywheel of value creation and hopefully accelerate a lot of early stage academic technologies to market.
Awesome. And we still have a few more minutes of this show. Guys, if there's any questions from the audience, feel free to request to speak, and I'll let you in here on stage with our guests, with our speakers. Or you can also put in a comment and I can read it out if you're just a little bit shy, but there's nothing to worry about. Guys, David and Albert, obviously I'd love to hear some of your final thoughts as well. I do have one more question that I really wanted to get your opinions on. Let's talk about the bigger picture for a second. We have been discussing DeSci and the innovations in the space for the majority of this Twitter spaces, but there's a lot of talk about the future of DeSci. Some people have been saying that DeSci might be dead. Obviously it's not, but some say that it's the next big thing. We know CZ, different from Binance, different panels all around the world, different events mentioning DeSci and AI as the big catalyst for the next pump in crypto. But others also say it's just a passing trend. And I know the answer to me, right? Like, obviously, DeSci is absolutely not dead, but I wanted to hear a little bit more from your perspective, especially David, if you can go first and tell us a little bit more about the most exciting initiatives that you're kind of part of, you're working on, you're helping, other students as well to work on.
Yeah. Is DeSci alive or dead? What an interesting question. It's funny. I'll share just like a little anecdote. When I've been doing How to Grow since probably back, 2016, 17. And I'm also the founder of this event called the Global Community Bio Summit, which is another kind of DeSci adjacent network of kind of global community biology labs. And we've been hosting this event at MIT since 2017. We did 3 in person, 3.5 virtually. And it basically was bringing together this network of folks doing kind of grassroots biology, biohacking. And when I first started doing that work, I got connected to this gentleman who was the founder of the Harvard Bitcoin Club. This was back in I think it was 2017. And his name is Josh. And he was like, "Oh, Josh," was like, "Hey, do you know what's going on with blockchain?" And I was like, "Not really." It's back in 2016. And he's like, "Well, there's a bunch of guys you should meet who are building out this whole thing that's very, very kind of similar values wise to what you're doing." And I was like, "Okay." And so back, probably 16 to 18, I met, a whole bunch of, I think, who have now become a lot of the key figures in crypto. Folks like, Fred Ersham and, whoever else at that time. And I remember having these meetings where, I was explaining what we were doing both with community biology, but also even back then, the kind of early, seeds of How to Grow. And yeah, there was all this kind of like, whoa, yeah, we're doing a very similar type of thing, except in this other kind of technical domain, but a lot of shared values online, right? I think this whole idea of being able to have, decentralized networks, doing cool things together, and having a technology that could enable that is super exciting. So anyways, I think there's been kind of these really cool parallels between DeSci or crypto, blockchain, and biotech or at least from my view, for a long time. So I would love to see all of this kind of get scaled and manifested in some more powerful ways, right? I mean, I think the projects I was hearing you guys just talk about with, the chocolate. I'm a big chocolate guy, actually. So the DeSci chocolate sounds great. But yeah, I mean, I think you got to have a few early wins to show the power of the network. And we're doing something similar too, obviously. We're trying to show that doing collaborative science using a scalable network can produce something exciting and different than you could just as like a siloed lab, right? That's actually like something we're actively trying to show with what we're doing. So I think those types of demonstrations are important. And I would just say in general, to your question about like kind of what's cool happening now or the types of things that I want to see more of, I am definitely like wanting to see more just big global collaboration, big global projects, things that show that it's possible. And we know it's possible, but even now, I think through technological mediation, it could be even more just part of our everyday experience to be working globally to solve big problems. Both for the Bio Summit and also for How to Grow over the years, like one of my most inspiring feelings is sitting in a room, virtual or in person, but usually virtual, with just people all around the world that care about trying to get done certain similar things that have shared values around innovation, education, learning. And it's so inspiring to feel like, hey, we can do this together, right? If you look at the scale of the challenges that we're facing, I mean, there's civilization scale challenges and they require civilization scale response, So I think for us to get to that level of scale requires some level of technological mediation and infrastructure. So that for me is the vision that gets me excited.
Amazing. Thank you. And Albert, Dan?
Yeah, I think if the market is doing well, then everybody's like, hey, DeSci is the next big thing. If the market is not doing well, DeSci is dead, nothing is happening. And I think the people who are actively working in DeSci right now just sees things from a whole different perspective. There's just so many projects being actively built on right now. The party hasn't stopped. It's just, we've just lowered the volume a little bit because the neighbors are complaining. But then, once they go on holiday, we'll be back up and increasing the volume. And I can just say, like last week, I was in Berlin at the BioXYZ Biohackathon, where the focus is going to be a lot on AI agents and how they can help science and automate a lot of, the knowledge work needed to get a project off the ground. And I think we're just scratching the surface of that particular area. And I think there's going to be a lot of DeSci projects working, particularly in this domain, because, software, it's scalable. We can ship things much faster. And I think a lot of that is going to be translated into real research impact one way or another. Our project, so we're also going to participate in this hackathon because we're as part of our product initiative. So we could use some of the work that we've done in our product development and participate with that in the hackathon. And our goal is going to be to close the digital to physical biotech loop. So flow, as I mentioned, it's, you basically input your research details, what experiments you've done and what data you've had and so on. And then it generates a new experimental procedure for you that you can pursue. And so what we want to do there is, can we get an agent to essentially program an open trans machine, for example, conduct the experiment, analyze the data, and then essentially re-upload that data back to the agent, have the agent analyze it, and propose a new experiment. And so that's what I'm really, really excited about. And like that's some of the stuff that David, you probably have a lot of experience with, and probably one of the main goals at How to Grow, right, is to close that digital physical biotech loop and just explore new ways that automation can take place. And I think there's just so much to learn, and people all constantly complain about capex and biotech is so expensive, but I think it's more of a creative problem and not so much of like a limited infrastructure problem.
Well, I think it's definitely a creative problem. Hopefully, it will become less of an infrastructure problem, although I think it still is a significant infrastructure problem. But I mean, I love what you're saying, and we're obviously big believers as well in automation and robotics as a way of getting just a lot more people working in the field. I mean, it's kind of a mind-blowing thing because, like, it's possible with an internet connection and a computer, you can learn how to code. You can basically, do anything in the digital world with those two things. But you've always needed to be in person with a wet lab, And so just having robotics that can be engaged with remotely, I think is a huge game changer for quote unquote hands-on science, and I think as in general, even if you're in person, things are going to increasingly shift more to robotics. And that kind of connection between interoperable code protocols and, kind of the larger, digital infrastructure, there's so many possibilities, I think, for what's possible and what can be done.
Absolutely. Dan, would you like to jump in here as well? And then I'd love to hear the question from Max, who's just joined us.
No, I'll turn it over to Max.
No worries. Max, welcome to the stage.
Thank you. Hey, everyone. I had a question about kind of like, so if you're a young scientist interested in industry and motivated about making changes along the lines of biomanufacturing, industrial biomanufacturing, you guys have brought up interesting points about decreasing capex, decentralizing science, and trying to make it lower the barrier to entry effectively to make a change in this industry. I'd be curious to hear thoughts about going to go get a PhD and how that plays into the future of the science and people wanting to make impact, especially along the lines of the industry and academia bridge.
It's a great question. So one thing that I see is super creative, talented people from so many different domains getting into biotech and it really changing their lives and their careers. I think one thing How to Grow has been really good at over the years has been kind of being that gateway into bio. You know, you can, through something like How to Grow, where you get like a 3-month kind of experience, and then it really, rockets and catapults you into this field, I think, in a way that is really exciting. So that's kind of, I think experiences like How to Grow, I think, are very useful for that. There is then the question of you're getting at, which is like, depth and technical depth. And so it's hard to replace the experience of something like a PhD where you spend many years of just dedicated focus on developing your both research skills in a specific domain, but then what I would argue is the most important thing you learn when you get a PhD, which is you learn how to learn. Right? I think that is actually the most important thing you do is you figure out yourself and you figure out how to construct mental models for things and how to actually teach yourself things. Because that's the whole point of a PhD is you're doing new stuff that nobody else has done before. So that experience, I think, is achievable without a PhD, but the structure of a PhD is extremely useful in getting that kind of learning juice out, so to speak. So anyways, but I think increasingly over time, especially in bio, we're going to see the ability for folks who do not have full-on doctoral training to still produce all kinds of creative, exciting things, which I see every year in How to Grow. But for now, at least, I think it's still hard to replace some of the deep kind of domain and other expertise you get through an actual doctoral program.
Thank you. That was super insightful. I also just wanted to say, I went to school as a neighbor to MIT. I went to Tufts University. Always good to see a fellow Bostonian.
Hey, shout out to Tufts.
Love this, guys. Okay, I think this is pretty much the end of our show. Max, thank you so much for the question. And yeah, it's been an incredible conversation with you guys, David, Albert, Dan. Thank you so much for joining us, and thank you for discussing the future of DeSci, how it's evolving, the programs, how to educate people, the innovations. Thank you for updating us on the Cocoa Zero, and how are we actually changing the way we approach sustainability in biotech. And guys, if you want to stay up to date with all the latest developments in DeSci, please follow ValleyDAO. Please follow our speakers, Albert, Dan, David. Give a follow to Max as well. And don't forget to tune into our next episode. This show is going to be published on Spotify, like I said at the beginning, Google Podcasts, Apple Music. So make sure to go and subscribe to us over there as well. You can choose from all the major streaming platforms. And you can always join the conversation, stay connected on our Telegram, Discord, and here on Twitter. Guys, thank you so much once again. Let's keep proving that DeSci works. And yeah, see you soon.